Hi, I'm Dilraj.
I'm Tritin.
Hi, I'm Farah.
Hi, I'm Sharifah.
And hi, I'm Elfie.
We are from Group 18.
Please enjoy our sedimentation video.
Hello guys, my name is Sharifah. So now I will move to the first part, which is introduction. So, sedimentation is the tendency for particles in suspension to settle out of the fluid in which they are entrained. The flock from flocculation move through large tubes. The water moves through these basins due to their large size. The flock settle to the bottom of the basin due to gravity. Sedimentation process removes many particles or separate particles, including clay and silt-based turbidity, natural organic matter, and other associated impurities. The most common sedimentation process used in our daily life is water treatment process. Solid particles entrained by the turbulence of moving water may be removed naturally by sedimentation in the still water of lakes and oceans. Settling basins are ponds constructed for the purpose of removing entrained solids by sedimentation. Clarifiers are tanks built with mechanical means for continuous removal of solids and being disposed by sedimentation. Natural and wastewater contain small particulates. They suspended in water forming colloids. These colloids carry the same charges and repulse prevents them from combining into large particulates to settle. This process are called coagulation. Another method used in wastewater treatment is high molecular weight material attract or trap particulates and settle down together. Process is called flocculation. Starch and multiply charged ions are often used in flocculation. On the other hand, in our experiment that we have done, we learned about the sedimentation studies apparatus. The main objective of the experiment is to study the different characteristics of sedimentation by using tapioca and aluminum oxide. Theoretically, the higher the suspension height, the higher the settling rate, and the higher the concentration used, the higher the settling rate. So now, next, we move to the customer requirement. Our country has almost 27 million people who generate 6 million tons of sewage every year, which is treated and released into rivers or the sea. Regular treatment of sewage is paramount as 98% of Malaysia's fresh water. Raw surface water becomes contaminated as a result of excessive and indiscriminate discharge of wastewater directly from households or factories. This impairment of water quality greatly decreases the usability of the water and will create a hazard to public health and sea creatures. In response to highly demand for a better and effective sanitation services, government and private companies have encouraged to build wastewater management systems. The needs for the very high quality processed water in a number of applications will support greater demand for technologies such as reverse osmosis, ultrafiltration, nanofiltration, and disinfection equipment. Water treatment equipment demand in manufacturing markets will also benefit from the recycling of wastewater. Wastewater treatment is removal of floating solids through sedimentation. Coagulation and flocculation can be used for building a compact treatment plant. The sedimentation process in wastewater treatment used in many applications included to factories to produce clean solution, liquids, chemicals or drinks, and households for drinking water and fresh water to bulk. So, to be concluded, wastewater treatment is very important in our daily life to to have continuous source.
Yes, so my name is Dilraj and I'll be talking about the process description. Before I move on to the process description, I want to let you guys know about a concept that I think you should already know, which is the process flow diagram. Process flow diagram is basically a type of diagram used in engineering, process engineering or chemical engineering to show the flow of a process. This diagram mostly focuses on the major components and the process. It rarely goes into the details of the thing. So let's zoom into our process flow diagram. Alright, so basically this is how the process flow diagram of our plant looks like. I'll explain every single one of these features in more details in a minute. Alright, let's look at something more industrial-like. It's basically the same thing you just saw 2 minutes ago, but this is more of industrial where we actually can see how the equipment looks like and how does it actually relate to one another. So let's go to the first part of it. The first part of it is screening. Screening is the first step in water treatment, where what happens in screening is just that the whole raw water goes through large metal bars where the large particles like large live animals, large wood, large pieces of metal all are removed from the system. Alright. Next what happens is it goes to the rapid mixing stage. In the rapid mixing stage, basically chlorine is added to it. Chlorine is added to arrest any growth of biological materials. Alright, for example, algae can build up in this system. Okay, algae build up, firstly, it can cause blockage in the water distribution system itself. Right? If it is blocked, the process has to be stopped and it needs to be backwashed just to clear the blockage. This takes a lot of money and time. Other than that, algae also creates a very different odor and an unpleasant taste in the water treated. Second part is coagulation. This part, basically liquid aluminium sulfate, which is also known as alum, is added to raw water. Okay, when mixed with the water, this basically causes the tiny dirt particles to actually coagulate together and form a larger, heavier particle called flocks. Alright, so flocks are much easier to remove by settling and filtration. Next, the system moves into sedimentation, where basically at this part, the water moves very slowly, so the heavy flock particles due to their big density will eventually settle at the bottom of the chamber. Right? The flocks which are settled at the bottom are later piped to drying lagoons. Okay, so the next part is the top water, the clean water will be moved to the filtration stage. Filters are basically designed to remove particles in water. The filters are made of layers of sand or gravels. This collects all the suspended impurities in water and enhances the effectiveness of disinfection. Okay, and lastly we have is disinfection. Disinfection is where water is infected before it enters the distribution system to ensure that any disease-causing bacteria, viruses and parasites are destroyed. Chlorine is used because it is effective disinfectant and residual concentration can be maintained to guard against possible biological contaminations in the water distribution system. Alright, so let's look at mini processes that also involve the sludge that is removed in the sedimentation stage is further on put at sludge drying. Sludge drying is basically the solids that are collected are settled out by water sedimentation and filtered are removed to drying lagoon. Alright, so next it goes through fluoridation, the treatment of community water supply for the purpose of adjusting the concentration of free fluoride ion to the optimum level sufficient to reduce dental caries. Alright, the clean water lastly has to go through a mini process which is called pH correction. So basically here lime is added to adjust the pH and stabilize the naturally soft water in order to minimize the corrosion in the distribution system, because distribution system is mostly made out of metal. So if the pH is not right, the corrosion speed will be increased. Alright, so So let's move on to the next part, which is equipment list and unit description. So this is basically our apparatus, right? The sedimentation studies apparatus, which consists of three main parts: the bench, the ring holder, and the cylinder itself. Okay, the bench is basically a high quality lab material, okay, which is also chemical resistant. This is where all the components are placed and mounted. Okay, there is also, okay, as you can see here, this part, as you can see here, this is the part where this is the back panel of the bench, where basically fluorescent lights are there. Okay, fluorescent lights on in order for us to make it easy for us to actually determine the height. The next is cylinder. It's basically 5 equal sides of 53 mm outer diameter glass cylinders mounted on a vertical back panel, which is illuminated from the back. Alright, so the cylinders are made from borosilicate glass. So that's about it for the cylinders. And lastly is the easy one, is the ring holders. It's just to hold the cylinders to the bench. Other apparatus used is beakers. We have used 2 beakers, each the capacity of 2000 milliliters, made of polypropylene, and are supplied. We use this thing basically to prepare the solution for the experiment. Lastly is the stopwatch, which is used to determine the time of the sedimentation. Okay, so that's about it for the presentation. So I'll move on to the next part. We will be looking at the operation description, which is basically 3 simple things. Firstly, filling up the cylinder. The solution is prepared in another beaker and just poured into the cylinder. Secondly is fitting the cylinder. Just hold the middle and the bottom part of the cylinder and push it gently against the ring holders. This will secure the cylinder to the back panel. And thirdly is just to on the power cord at the back, to on the back panel illumination. This ensures a more accurate reading of the sedimentation process.
And I will be presenting about the result and discussion. For this experiment, we are dividing the experiment into 2 parts, which is experiment A. We are going to study the relationship between the settling rate for suspension at different initial height and different concentration. And for experiment B, we are going to study about the relationship between the settling rate and volume of flow current. For suspension at different initial heights but same concentration, cylinder 2, 4 and 5 are compared. Graphs are plotted based on the 3 cylinders. Theoretically, the lower the initial height, the higher the settling rate. This is due to gravitational force acting on it. However, from our experimental result, we get the same settling rate as the gradient for the 3 lines are the same. We can see from our graph, the gradient of the 3 lines are almost the same. This may due to the short period of settling rate during the experiment.
It shows that cylinder 1 has greater gradient than cylinder 2. Hence, we can conclude that the lower the concentration of suspension, the greater the gradient, and hence the greater the settling rate. For experiment B, we are going to discuss about the relationship between settling rate and the volume of flow current. We expected that with the adding of flow current, the settling rate will be increased. The higher the volume of flow current, the higher the settling rate. The reason is because flocculation occurs with the presence of flow current, in our case, which is aluminum oxide. Aluminum oxide brings the particles together, coagulate them together into a larger and denser particles, and hence increasing the settling rate. The data shows that with the presence of flow current, there is slightly increase in the settling rate compared to the cylinder without flow current. However, our data doesn't show the trend that settling rate increase with the volume of flow current. This may due to some experimental error and also short period of experiment.
Recommendation. We found 3 errors in our experiment, which is instrumentation error, tolerance error, and also human error.
operator actually?
Plant operator can be defined as a worker who controls treatment plant machineries and equipments to purify and clarify water consumption and for industrial use. As it deals with machineries and equipments, it is considered to be dangerous. Why is it dangerous though? While handling large amount of water, accidents may occur, such as falls, slips and trips due to wet floor or condition. Sudden release of toxic material can cause exposure to hazardous substance. Other than that, as it deals with electrical equipments, electric shock also might probably to happen when in contact with live wires or defective electrical installation. Some of the equipments make very high noise while in operation and can cause exposure to a high level of noise. As many chemicals is used in wastewater treatment, it causes exposure to various disinfectants, which are harmful for our body or in contact. Other than physical problem, it has an effect towards one's emotion and psychology. Psychological stress and pressure might happen to the plant operator due to some environmental factors such as annoying noise, water splashing odors, or high humidity. As the job is considered to be dangerous, the plant operator need to take some preventive measure to prevent accidents from happening. To prevent from slipping or walking on wet floors, the operator needs to wear safety shoes with non-skid soles. Secondly, it is also advisable to ensure that the ladders used are in good condition, as this is also applies generally to any other equipment used. The places with high potential of accidents or falling to occur should be securely fenced by appropriate railing guards. Other than that, it is also essential for operator to wear clothes that are attached to the body. Other recommended accessories is that the plant operator to wear headgear and also install guards to all moving parts of the equipment that may likely to cause injury to the plant operator. Last but not least, it is also advisable for the plant operator to call a qualified electrician to inspect equipment frequently or do a general checking before using the equipment. Who knows, it might save your life. Okay guys, let's move on to the next slide, which is entitled Chemical Handling and Safety. As it also deals with chemicals and various amount of and concentration, we also need to know how to handle the chemical and its safety measures. Most of the chemicals that are being used are hazardous type and require extra handling. Some of the examples of exposure to various disinfectants are chlorine gas, which is known as strong oxidizer and disinfectant. Even at low concentration, it can cause irritation to the eyes or respiratory tract. Another example is that hydrofluoric acid, which is known as a strong acid that is being used in water fluoridation. Other than that, sodium hypochlorite is also has toxic and corrosive property similar to chlorine gas. It can cause burns and irritation to the eyes and skins as it's very corrosive.
Example of exposure to these disinfectants is ozone. What is ozone actually? Ozone is an oxidizing or irritant gas, which if we inhale, it may cause breathing difficulties, fatigue, eye irritation, and tears and conjunctivitis.
Now I will proceed to the economic analysis part. It is difficult to estimate the specific cost of a water treatment facility because it depends on the design of the water treatment system, as different places will use different design. Hence, the costs for a typical water treatment plant are very site-specific, and it is necessary to develop for individual circumstances. For general conventional surface water treatment plant, it is required to consider the designs and the components for the facilities, which depends on the quality and characteristic of the raw water primarily. Factors such as water right cost, initial construction cost, continue operating, and maintenance costs and capital replacement costs must be included in account for the total cost for a typical water treatment plant. In order to study the economic cost for a conventional surface water treatment plant, we refer to a case study done by Kelly Sue Rogers on the McAllen Northwest facility. This case study provided an estimation of the life cycle cost of conventional water treatment by utilizing actual data from an operating surface water treatment plant located in McAllen, Texas. According to this case study, it is also mentioned that the total cost of this water treatment plant are compiled of the water right cost, initial construction cost, annual operation and maintenance, chemical and energy costs. From this case study, McAllen Northwest facility spent total up to $20.4 million to purchase permanent municipal water right. For initial construction costs, they spent $22.96 million, and it took 24 months to be successfully constructed. The continued cost would be $1.77 million per year. For a water treatment facility, the cost for capital replacement items are estimated at 2.043% to account for inflation of the total cost. Overall, from the case study done by Kelly Sue Rogers, we can see that the total construction cost for a typical water treatment plant with mentioned operating units is approximately $23 million. We also refer to the Illinois State Water Survey done by William C. Ackerman. From this survey, Figure 3 shows the relationship between the total cost of surface water treatment in cents per 1,000 gallons and the water treatment plant normal capacity in MGD. The total cost to produce 1,000 gallons of water consists of 50% investment cost and 50% for other costs as follows: 20% manpower, 17% energy, 7% chemicals, 2% maintenance, 2% repair, and 2% heating. In addition, a capital cost of 2% of the investment cost is added for taxes and insurance. The investment cost is amortized at 4% for 30 years. From this survey, the surface water treatment costs include purification and chlorination. Normal purification consists of chemical coagulation, sedimentation, and rapid sand filtration. All costs are based upon the design plant capacity in MGD.
This case study gives a detailed insight on the significant factors of cost in water treatment process.
Now we have reached the conclusion. We have conducted two different experiments. The first experiment was conducted to study the impact of the known initial height and the concentrations of the settling rate. The higher the initial height, the lower the settling time. This is due to the gravitational force acting on the movement of particles. The higher the initial height, the higher the gravitational force, and the lower the settling time. For the second experiment, which was conducted to study the settling rate for different volume of flocculants,
which is aluminum oxide plus tapioca solution. The observation it can be concluded that the settling time for each cylinder decreased compared to experiment 1. The higher the liquid level, the lesser the effect of flocculants on the settling rate. That's all from our group.
How was the video? Was it nice? Please leave your comment below.
Subscribe to our page.
Thank you for watching.
Bye.